So in 2016, a Japanese cell biologist named Yoshinori Oshumi won the Nobel Prize in Physiology or Medicine. Not for discovering a new drug, not for a surgical technique, but for discovering what your body has been doing automatically since you were born, every time you go long enough without food. He called it autophagy. The Nobel Committee called it one of the most important discoveries in modern medicine. The wellness industry called it a buzzword and kept selling you breakfast. Today, the actual biology, what your body does when you stop feeding it. Why feeling low energy during a fast is almost never what you think it is. And why this practice lands differently in a female body than a male body, and what to do about that. Last episode, the convergence, every serious tradition on earth independently arrived at fasting. The Sufis, the Hindus, the Christian desert fathers, the Buddhist monks, and the Jewish prophets. They weren't after weight loss. They were after what surfaces when the comfort was removed. Today, we're going to dive into biology because you cannot use a tool you don't understand. And most people fasting right now are operating completely blind to what the tool is actually doing. So the biology, simple enough for anyone to follow, deep enough to actually matter. And before we get to fasting itself, there's one idea that you need to know that changes how you understand everything else. So here's the thing nobody tells you first. Your body does not run on food. I know what you were taught. Food gives you energy. Calories in, calories out, hit your macros. It's not wrong. It's just incomplete in a way that matters enormously. So let me give you an accurate version, right? Think about a fireplace, right? You throw a log on the fire. The log doesn't heat the room directly. The fire converts the log into heat, which warms the air, which warms you. The log is a raw material. The fire is the converter. The heat is what you actually feel. Your body works exactly like that. Food is the log. The cell, specifically a tiny structure inside it called the mitochondria, is the fire. And the heat the body actually runs on is a molecule called ATP. ATP is the only energy your cells can actually spend. Every time you lift something, think something, and breathe, that's ATP being used. Food never becomes ATP directly. What happens is this: your gut breaks down the food into smaller pieces. Those pieces get passed into your cells. Inside the cells, those pieces get broken down further, and the energy locked inside them gets extracted step by step, like water moving through a series of locks in a canal. At the end of that process, a tiny molecular machine spins and produces ATP. It literally spins like a turbine inside the cell. Peter Mitchell described this mechanism in 1961 and won the Nobel Prize in chemistry for it. Here's the takeaway in plain language, right? Food is the raw material. The mitochondria, those tiny structures in your cells, are the converter. ATP is the actual energy your body runs on. And when you fast, you haven't removed your body's energy. You've just removed one type of raw material. The converter has another one ready. It's been storing it for exactly this moment. So you stop eating. Your body processes the last meal. Blood sugar drops. The hormone insulin drops with it. The body starts using up its quick access storage. Glucose packed away in your liver and your muscles. Picture a backup generator kicking on when the main power cuts. In most people, that backup storage runs out somewhere between 10 and 14 hours after the last meal. That's the moment most people panic. They feel foggy, tired, irritable, and they conclude, I'm running out of fuel. I need to eat. Here's what's actually happening. The body is not running out of fuel. It is switching fuel sources, like a car that can run on two types of gas. It just finished the first tank and now it's switching to the second one. The second fuel source is fat. Your body breaks fat down and converts it into molecules called ketones. Ketones goes into the same converter, the same mitochondria, and produce ATP. Same engine, different raw material. George Cahill at Harvard spent decades studying exactly what the human body does during periods without food. His research, published in the Annual Review of Nutrition in 2006, is the definitive method. His finding is that the body is incredibly good at running on fat once it makes the switch. Most people just never let it get there. And here's where it gets really interesting. Right? The brain, which normally prefers to run on the first type of fuel, turns out to love ketones. Dr. Mark Mattson at Johns Hopkins, one of the most cited neuroscientists in the world, found that fasting increases ketone levels in the blood by up to 20-fold. A strict keto diet only increases them 4-fold. Fasting is 5 times more effective at producing them. And ketones don't just fuel the brain, they send it a signal. And we'll get to that signal in a moment. Now, the most important reframe in this entire episode, if you've ever fasted and felt genuinely terrible, not just hungry, but foggy, weak, unable to think, you probably decided fasting doesn't work for me. My body needs food. With all due respect, that's almost certainly a misread. Here's the analogy. Imagine someone who has only ever driven an automatic car. You hand them a car with a manual transmission, a stick shift. They stall, they lurch. It feels wrong. It feels like the car is broken. The car is not broken. They just don't know how to drive it yet. That's what's happening when you fast and feel terrible. Your body has been given glucose, the automatic transmission, every 2 to 3 hours for years. The mitochondria have never had to learn how to switch to fat. When you remove the glucose, they stall, they lurch, they make you feel like something is wrong. Nothing is wrong. The engine just doesn't know how to drive the second type of fuel yet. Here's the thing, most people carry enough stored fat to fuel themselves for weeks. Even a lean person has thousands of calories of stored fat available. The tank is not empty. The driver just hasn't learned to use what's in it. Every fast you complete is a driving lesson for your metabolism. Every time you let the glucose run out without immediately replacing it, the body gets a little better at the switch. The fog gets shorter, the stalling happens less, and eventually the switch becomes so smooth you barely feel it. The low energy most people feel when fasting is not the body saying stop. It's the body saying, I haven't done this in a while, give me a moment. While the fuel switch is happening, something else begins running at the same time. The process that won the Nobel Prize, autophagy, Greek for self-eating. Here's the simplest way to understand it. Think about a city. Every city produces garbage, old buildings, broken equipment, waste material. During busy times, when the city is fully operational, that garbage starts piling up. The cleanup crew is there, but they can't keep up with everything coming in. When things slow down, when the city gets a break, the cleanup crew finally gets to work. They go through everything, they break down what's been broken, recycle the material into something the city can use again. That is autophagy. Your cells produce cellular garbage all the time. Damaged proteins, worn out parts, things that just stopped working. When you're constantly eating, when insulin is always elevated, the cleanup crew almost stays dormant. When food stops arriving, when insulin drops, the cleanup crew gets the signal it has been waiting for. Yoshinori Ozumi spent years proving how this works at the molecular level. And inside autophagy, there's a specific process that matters especially for anyone who trains. Mitophagy is when the cleanup crew targets the converters themselves, the mitochondria. Think of it this way. A factory has machines. Some of those machines get old, inefficient, partially broken. They still run, but they waste energy and produce less output. Mitophagy is the factory, identifying those underperforming machines through a two-protein quality control system called PINK1 and Parkin, pulling them offline, breaking them down, and replacing them with new, more efficient ones. The cell identifies damaged mitochondria by the drop in their performance. PINK1 spots the underperformer, Parkin tags it for removal. The lysosome breaks it down, a better mitochondria gets built in its place. So when you feel that low energy dip during a fast, part of what you're feeling is the factory pulling old machines offline to replace them. It's uncomfortable. It's also exactly what needs to happen. You're not getting weaker during that window. You're being upgraded. Okay, now back to the brain, right? When ketones start arriving, when the fuel switch completes, the brain doesn't just get a new fuel, right? It gets a message. The message triggers a molecule called BDNF. Think of BDNF as a fertilizer for brain cells. When it's present, neurons grow stronger connections. New neurons form in the memory centers. The brain becomes more resilient, more adaptable, harder to damage. When it's low, the brain starts to lose ground. Low BDNF is connected to depression, memory loss, and diseases like Alzheimer's. Matson's research, published in Nature Reviews Neuroscience, showed this directly. When ketones enter neurons, they trigger BDNF production. The switch to fat fuel doesn't just keep the brain running, it activates a growth program the brain rarely gets to run on a normal eating schedule. That sharpening you feel around hour 18, hour 20 of a real fast, that clarity after the fog, that's your brain on ketones, producing BDNF, building itself. The mystics wrote about this state for thousands of years. The neuroscience is now showing exactly why it happens. I want to be clear before I say anything else. Women can fast. Women have been fasting across every serious tradition for thousands of years. The female body is not fragile, but the female body is also not the same as a male one. And applying the same fasting protocol to both without acknowledging the difference is like using the same training plan for a sprinter and a marathon runner. Same sport, very different demands. Here's what's different. Everyone, male and female, runs on a 24-hour rhythm. Light and dark, sleep and wake, cortisol rising in the morning, melatonin rising at night. That rhythm is universal, along with their lifestyle. The female body carries a second rhythm on top of that, approximately 28 days, the menstrual cycle. And that second rhythm changes almost everything about how the body handles stress, including the stress of not eating. Think of it like the ocean. The ocean has daily tides, in and out every day. But it also has spring tides, bigger tides that happen with the new and full moon. A sailor who only knows about daily tides will get caught out. A sailor who knows both rhythms navigate differently, more precisely. The female body has both tides, and fasting is not the same experience at every point in the 28-day cycle. So here's the biology simply. Deep in the brain, there's a gatekeeper molecule called kisspeptin. Kisspeptin controls the signals that run the menstrual cycle. And kisspeptin is wired directly to the body's energy sensor. When the body senses that food has been scarce for too long, when it reads the energy deficit as a real threat, kisspeptin starts to pull back the signal that keep reproductive system running. The body is making a logical decision. Survival comes first, reproduction comes second. If there isn't enough food, this is not the time to prepare for a child. So the system quietly starts to turn down. Cycles get irregular, longer, shorter, or they stop. The body cannot tell the difference between a therapeutic fast you chose and an actual famine. It reads the energy signal, not the intention. This is not a reason to avoid fasting. This is a reason to understand your rhythm well enough to work with it. Here's what the research shows about two halves of the cycle. The first half, roughly days 1 through 14, this is called the follicular phase, right? Estrogen is rising, the body is more resilient, energy is more stable. The body handles the stress of fasting better during this window. Longer fasting periods, 14 to 16 hours, are generally well tolerated here. The fuel switch happens more cleanly. The cleanup crew runs more efficiently. This is the time to practice fasting if you want to practice it. The second half, roughly days 15 through 28, this is called the luteal phase. Progesterone rises, body temperature goes up, appetite increases, the body becomes more sensitive to stress signals during this phase. When you add fasting stress on top of that, the stress hormone cortisol rises more sharply. And elevated cortisol actually suppresses progesterone, which makes the second half of the cycle harder, which amplifies PMS, disrupts sleep, and over time, if you push through it repeatedly, can throw off the cycle. During this phase, shorter windows, 12 hours overnight or no structured fasting, not because you can't, because you're working with the tide rather than against it. And the body will tell you when you're pushing too hard. If your cycles become irregular, if they lengthen, shorten, or disappear, that is the kisspeptin system sending you a message. The deficit is too aggressive for where you are in the rhythm. Listen to it and adjust. We are all part of nature. Everything in nature runs on rhythms. The moon, the tides, the seasons, the day and night. The female body carries those rhythms inside it in a way most people never learn to read. It is the body embedded in the rhythms of the world it evolved inside. The Hindu tradition timed its fast to the lunar cycle twice a month, precisely at the 11th day after the new and full moon. They weren't being mystical, they were being accurate. They noticed the body responded differently to the same practice at different points in the cycle, and they adjusted accordingly. The modern fasting conversation removed the timing entirely, and the people it hurt most were the ones with the most complex biological clock. So learn your rhythm, not because it limits you, because without it, you're navigating with incomplete information. And incomplete information produces incomplete results. So here's a timeline, simple version, 0 to 4 hours. You just ate, right? The body is processing. Insulin is up, fat burning is off, cellular cleanup is on hold. 4 to 12 hours, the meal is fully processed, right? Insulin falling, body starting to use up its backup glucose storage. You may start to feel a little hungry. This is normal, right? 10 to 14 hours, backup storage is gone. This is where the fuel switch happens. For most people who haven't fasted much, this is the foggy window, the stalling, the undertrained converter learning to switch. 14 to 18 hours, ketones rising in the blood, right? The brain switching to the new fuel, BDNF production starting, the fog begins to lift. This is what the mystics described as the beginning of clarity. The science now has a name for why. 18 to 24 hours, autophagy running at full strength. Mitophagy engaging, the body identifying underperforming mitochondria and beginning to replace them. Growth hormone increasing to protect the muscle. This is the upgrade window. 24 hours and beyond, the cleanup crew still running, the converter rebuilding, the system getting cleaner and more efficient. The benefits extend for days after the fast ends as well. But where you are in your cycle shifts how every stage of it feels. In the first half of the follicular phase, the switch is cleaner, the fog is shorter, the upgrade more efficient. In the second half, the luteal phase, the same fast hits harder. The fog lasts longer. The stress response is amplified. The map is the same. The terrain it crosses changes depending on the season you're in. So know your terrain as well. So here's what to take from this episode. Your body does not run on food. Food is raw material. The log on the fire, the mitochondria are the converter, the fire itself. ATP is what the body actually runs on. The heat, the energy. When you fast, you don't remove your body's energy. You remove one raw material and ask the body to switch to another one it's been storing. If the switch feels bad, that's not a design flaw. That's an undertrained engine. So give it practice, get out of the way, and let it learn. When the cleanup crew runs, when autophagy and mitophagy activate, your body is not breaking down. It's rebuilding, pulling broken parts offline and replacing them with better ones. Every fast is a repair session. It's not just a deficit. And for women, the conclusion is not to avoid fasting. The conclusion is to know yourself well enough to time it right. Your cycle is not a barrier. It is the most precise information your body has about when it is ready and when it needs something different. So use it. The traditions that took fasting seriously, every one of them, built it around rhythms, lunar cycles, seasonal turning points, the natural pulse of the world. They were not being romantic. They were being precise about something modern fasting culture stripped out entirely. Episode 3, the psychological layer. The biology explains what happens in the body when you fast. It does not explain what gets revealed about the person inside. And that what gets revealed is the part every tradition was actually after. So I'll see you there.